So we're going to do a little introduction so you can get to know me. Then we're going to talk about what bad data looks like. We're going to talk about why databases are important, what an ERD is. It's so much fun. It's what the construction paper is for. We're going to talk about normalizing data, which is my favorite. And then we're going to create the schema, we're going to populate the tables, and we're going to rock and roll from there. So I'm Claire Tolbert. I'm a .NET developer at Alkami up in Plano. I've been there for just about a year now. I'm also the Dallas director of Women Who Code, so some of you might be here because of Women Who Code. Rock on. And if you don't know about that, ask me about that after, and we'll get you all signed up. I went to college in the Oklahoma Panhandle at Panhandle State, and that's sort of where I got my whole start of love of .NET and databases. The dean of my department is obsessed with databases, so I think her love just sort of flowed into me. So I love them, and bullet journaling, that's like the other half of my life is my bullet journal. And then I interned in a cattle company in college, which you wouldn't think that they need developers, but they do. And that's actually where I got to start designing databases from the ground up. So I wrote them 6 products while I was there, from database design to production, that are still in production today, which is really cool. So I was spoiled there. Now I'm my 4th job in the industry, and I don't think I've ever gotten to design a database myself. That's sort of the nature of it. So let's jump right in. Let's talk about what bad data looks like. When you are working at like a little mom and pop shop, or you have a summer job at something like, a little restaurant or something, or what we're going to use tonight is a movie rental place. And someone says like, okay, I need you to do some data analytics, and they hand you a spreadsheet that looks like this. It is not a fun time. This is the worst, and it's meant to be ugly on purpose. I promise the rest of my slides aren't this ugly. So let's sort of go through and look at this about why. Actually, I'm going to turn it on y'all. I know it's probably a little bit hard to see, but what do you think is bad about what you see up here? There's no wrong answer. Yeah? Yeah, there's no wrong answer. Huh? Yes, it is hard to read. It's really hard. We see a lot of the same data over and over. So you see like every time Michael Scott comes in, these are all the Office characters renting Pixar movies, by the way. Every time Michael Scott comes in, we're taking down his first name, his last name, his phone number, his account number, over and over and over and over again. How many times is his name gonna change? Probably none. How many times is his phone number gonna change? Maybe, but we can update that in one place. We don't need to write it down every time he comes in. Because now we're just repeating ourselves, and when we talk about real world, when you're buying storage space from Amazon, you're paying for almost like square footage, right? If you're thinking about storing things. And if you are storing the same thing over and over and over and over again, your storage needs are way bloated, and you're gonna spend more money. So we shouldn't be repeating this stuff. We should have Michael Scott's information written down once, and then reference it from then on. If he changes his name, if he changes his phone number, we can edit it right here, but we don't need to then go through this spreadsheet and update it every single time. This is just a glimpse. I'm sure Homeboy's here every weekend. So the other thing that we see is we have stuff in here that we don't really need. We've got movie genre. We don't need to write down the genre of every movie every time someone checks it out. We can just have that in one place. So we're starting to sort of see where we can break things up and what is important data to write down every time versus what is something to write down once. So something that is important to write down every time is checkout date, check-in date. That's going to change with every rental. So we need to know that every single time. We don't need to write all this other stuff. I also had slides for this, which is my bad. So there's Michael Scott. Every single time he has gotten something, that's really bloated, and obviously I cut this down just to fit this slide. His information would include his address, his city, state, zip, probably payment information, and now we're talking massive amounts of repetitive data. So same thing with movies right here. So let's talk about that. Generally, bad data is lots of duplicate data because you're increasing your storage requirements. It gets really expensive. It also has a lack of relationships. When we go back here, Michael is one person, and he has a last name, and he has a phone number, and those things are related to each other. When we're talking about Excel or Google Sheets or something, there's no way of maintaining those relationships and making the worksheet that you're working on and make those stay that way. You just have to trust that whoever's typing something in is typing in the right information. So all data is related and it should act like it's related, and then it's also really hard to analyze. When it comes time to say, okay, what was our most popular movie of 2018? What are we gonna do? We're gonna create a new sheet, right? We're gonna pull a bunch of data from the first one, make a pivot table, bring it to the second one, who's still with me, then we're gonna make a third one that's gonna create a chart based off the second one, and then you leave your computer for a night, you come back the next day, your chart's broken, it's game over. Like, it's just game, and you spent days on that. So what is beautiful about databases is that they are built to be analyzed and to be utilized in a powerful way that Excel is not. Come on in, there's room for everyone, and there's pizza too. I made it just for you, please enjoy. So let's talk about why databases are important, which we kind of already went over. They eliminate duplicate data, so we'll kind of go into this when we're drawing out our ERDs, but you are defining what we call data entities. So for example, we would have what we call a customer. A customer we define as having certain data attributes. So they have things like a first name, a last name, a phone number. And we just kind of put that in a box, and that stays right there. And then we can reference that later with different information. Oh my goodness, what is that, my dude? I didn't know he was coming. He was my good friend. So then we can kind of reference it just using something. So who remembers college? It was a blur, but I remember college. You get your little card, and you have an ID number, and that's like what you live and die by. You have to use it at the cafeteria, you have to use it in the bookstore, all that stuff. That is your unique identifier as far as the school is concerned. So when they're in their databases, they have assigned you this number 57423A, and you got to use that over and over and over again, because there might be more than one Michael Scott. There might be more than one Jim Halpert, but there's only one 47235A, or whatever the heck I just said. So that's a way of uniquely identifying you, and then we can relate that to other things later. So that's where we're talking about enforcing those data relationships. We say all of this data belongs to this one record, and they are related to each other, and then we'll reference it later. And then obviously we have endless analysis tools. Basically anything that you're using is built on top of a database as far as software is concerned. So anything, join us. Anything that has some means of storing data is referencing all of this. So then you have all kinds of data analysis tools that you can use, things like the data science industry uses, but then you can also do like local fun reports just for yourself on a Friday night. Okay, I'm so excited. I love database design. So first, we're going to draw an ERD, which is an entity relationship diagram. You're just that much smarter now. You're welcome. All right, so what is it? It is a diagram that illustrates the entities of a system and how they relate to each other. So really, it's just a way to map out your data. Really simple. Let's use an example, because you guys are going to do customer movie rental things. This is an example of what you'd use for students. So we have a student entity. So students have something like a student ID. They have a first name, a last name, social security number, date of birth, stuff like that. We're going to keep that in a box over here. Then we have courses that you can take. So they have things like a unique course identifier, the title, the description, maybe a professor ID. I left you a hint. Bonus points. I'm not authorized to give out any points, but bonus points to anyone who can tell me why you think professor ID is bold here.
For their classes.
Yeah, but so what else do we have on here that's bold? Let's rewind. It's boring to me. Oh, yes. I heard it like 17 times. I'm doing a good job. I'm just kidding. So yes, basically you'd have another table that has professor, and this uses professor ID to link to that, because you don't want to repeat yourself with professor information. And then a student can take many courses, right? And a course would have many students in it. So you don't want to store course information in your student table, because then that's a nightmare. You have no idea how many times. Listen, I had to take managerial accounting twice, so I would have had that twice in my student table. That would not be fun. But you also don't want to put student information in course, because then you have, what, 100 slots after all of this for all the names of all the students, and if someone drops out, you just have an empty slot there, pretty useless. So you want to say, okay, here's where courses stay, here's where students stay as far as data is concerned, and then here's where we track the relationship between the two of them. This student, Claire, is taking this class, database design. So all we really need between those things is the ID of me and the ID of that course, and then probably the grade that I got in it, or any other sort of information that's unique to that instance of a course and a student. Am I making sense? Are you with me so far? Okay. Have you ever seen anyone get so excited about databases? Not me. So now we're going to talk about normalization. So all this is talking about making sure that your relationships and your data should never be nested. So let's run with me real quick. We're going to run back. I know. Okay. So we've got a lot of relationships going on in here. Imagine this was one database table for a minute. We've got a lot of relationships going on in here, and they are nested in that you are keeping track of several different relationships in one place. We're maintaining relationships between customer information, movie information, and rental information in one place when each of those can be abstracted. There's room over here and there's room over there. Come on, join us. So you want to basically what's called normalize your data, which is like think of abstracting it up a layer. So for each of these, you could kind of have customer information specifically, movie information specifically, and rental information specifically. So, did I go too far? I skipped one, but that's okay. So now, you're gonna work together, group project time. Who's gonna be the slacker? Not me. You guys have paper and markers, work as a team at your group. I'm gonna give you a little bit of time. You're going to make an ERD. What does ERD stand for? Is it on here? Kill it. You're gonna make an ERD for whatever movie company you want, lackluster movie rentals. So go crazy, use your fancy markers. Nate put out like 47 pieces of paper per table. Thanks, Nate. So yeah, how about it? Go crazy, and then I'll just kind of come talk to you. We got like the best ERDs around, I know. So we're gonna do this category style, which we'll start with one team. We don't know which one yet. They're gonna read off what they have, and then everybody else, I just want to read off what you have that was not already said out loud. So I don't know that we all want to hear first name and last name 7 times. So who wants to go first? Don't all jump at once.
So we don't have to add on. I'd like to go first.
It's always easier when you're the first one. All right.
Okay. So we have two tables and then a bridge table in the middle. So our first table was movie, and we decided to have like movie ID, movie title, genre, and rating. Our other table was customers, customer ID, first name, last name, email, address, phone, and age. And then the bridge table in the middle was movie customer rentals, which would have the movie ID, check out, check in, payment, and then the 2 foreign keys from the customers and the movie ID bringing together.
Awesome. Love it. Who has extra bonus attributes? I saw some of y'all. Some of y'all wrote like 20 things down. Don't be shy now.
Yeah, all right. So we had a fee structure that would have been pulled in. It wouldn't have necessarily been part of the ERD, but it would have, when you pull in the other information, it would have been calculated off of the date out, the date in, and the due date.
Yeah. Love that.
As well as the potential inventory with movie ID, how many are in and how many are out.
Yes. Oh, bonus points for that. A lot of places will do that. So like to give an idea for this sort of inventory where you have, I might have 20 copies of A Bug's Life. So I need to identify which copy someone has. So instead of just A Bug's Life has this ID, I'm gonna have another table that's like movie title, and it's gonna have the ID of the movie, A Bug's Life, and then each of the unique identifiers of which specific copy someone has rented out. So that's a great point. Who else? Who else has some extra stuff?
I want just extra data points or extra entities?
Either is fine.
We had a little bit different take on the pricing table. It's just put them into categories like new releases, standard inventory, and then your really old stuff.
Yeah, because then you can sort of categorize them? Because you have like the 5 for 5 for 5 deal.
Drive your pricing.
Yeah. I like that one. That's the first time someone said it. Today. I'm just kidding. All right. Is that pretty much everything? Does anybody else have anything extra?
We had a like data format, Blu-ray, DVD.
Ooh, okay, fancy. Do you have VHS listed?
That and Laserdiscs was one of them.
Nice.
Then we had, what was it, the store number?
Yeah.
That way, if you wanted it somewhere else, you could find it in other locations.
Yeah, we were trying to figure out if format would be a whole separate table, or if it would be, a data point under movie. We were trying to figure out how it would best fit.
So here's an interesting thing. So there are levels of normalization, and basically, like the furthest you can go is this thing called Boyce-Codd normal form, and it's so specific. Here's an example of that, which will tie back into this. So Boyce-Codd believes that true normal form would involve removing zip code out of like a customer table and having that in its own table.
A lookup table.
And you would have a lookup table because you can look up city and state with zip code. So on your customer table, you would just have street address, and then you would have an ID field that would, a zip code field that would tie to zip code in your zip code table to look up all that stuff. But this is where I don't agree with Mr. Boyce-Codd himself, because when we're talking about realistic applications of these things, not theory, it is not realistic for a lot of companies to have, like maybe Netflix, fine, but a lot of companies to have a table that's every zip code in the United States, or if you're international, every postal code, everything in one table, just in case someone one day needs to reference one of those. It's a lot easier to just keep street, city, state, zip in one place. So for that, for format, you could make the argument that that should be its own table. You would have an ID, and then you have like description, like Blu-ray, and then if there's any data points beyond that that you would need to track, that's when I would probably move it to another table. But I don't know that there's anything beyond just Blu-ray or DVD, so then you could make the argument that it's just about like the difference in bits that you're storing in that one field is sort of negligible. So as far as as far as theory goes, yes, it should be its own table. I'll get really close to the mic. I'm just kidding. So as far as theory goes, yes, it should be abstracted and normalized, but yeah.
Isn't that part of the validation? Because I've seen it. The city, you put the state and the city zip code.
Yeah.
That validates it.
Right, so that'll be your...
Versus the other way, if there's not validation and that, justification for the business was to get, correct data.
Right, exactly.
Rather than garbage.
That's exactly right, and that's why we usually have validation on the front end, so that we can sort of strip out dirty data at the highest level, so that you're not waiting until it's a call to your database to insert data and it's too late. So maybe you could have some sort of validation. Usually it's a third-party provider that you call that has like all of the, when you're signing up for something and you put in your address and it'll be like, the USPS actually says this is your address, and it's like capital apartment. I'm like, okay, fine, Uncle Sam, you're right, it's capital APT. But yes, that's usually something that it's a different sort of call on the front end that's taking off, validating that, so that when they go to store it on their end, they know it's good to go. Okay, we good? Was there anything else extra? Do we have questions about an ERD? Do you feel comfortable drawing ERDs? The rule is you can only draw them on construction paper in markers. Ask anyone. Okay, so this was sort of talking about normalizing. Don't repeat yourself. Anytime you find yourself repeating data, that's when it should sort of be normalized into another table. So this is an example of an actual ERD for a movie rental company. It's meant to look sort of ridiculous and not be easy to read on this slide. But this is just to give you an idea of like, when you're talking about realistic applications, it's going to be massive amounts of data. If you're on a new implementation at work, for example, and you're talking to your client and they're describing what their thing is that you're about to solve with technology, what their program is or their whatever, you know, they're saying business things and you're hearing, okay, that's gonna be its own table, okay, the primary key is on this, and then you're asking questions like, okay, how do you validate that information? What's the unique identifier for your customer called? What is the format of that like? Is it all numbers? Are there characters involved? Because then you can make that integrity coded into your database to only allow numbers in the customer's unique identifier, or things like that. You can also code that on your front end or back end too, but it's just nice to like have a hard stop so you never have dirty data. So yes, this one goes into like payment. This one also normalizes address, which I don't really agree with. But anyway. So going back to our original thing, we should sort of start to be able to visualize how we would break this up for our schema today. On the far left, we have customer data. The middle, we have movie data. And then on the right, we have rental data. But why do you think the late column is not highlighted? Because you can just calculate that. You don't need to store that anywhere. There's no one at night at a movie rental place, well, anymore, ever, period. But, that's true. So there's no one late at night going through like the nightly report and typing in late. It's like, it's a report that's running, that's comparing today's date to the due date, and then it's flagging or sending out your email or calling your mom, whatever. So this is for the sake of our example tonight. This is our schema that we're gonna work with. Obviously, this could be enormous. This is just what we're gonna deal with tonight because we don't wanna get too crazy. So we've got movies, we've got a movie identifier. I've also just got some very loose data types next to here just to start getting introduced to data types. So we've got movie identifier, which would be an integer, meaning it has to be a whole number. You don't want a decimal in somebody's identifier. Maybe you do, like, what are those, the book identifier, what is it called, ISBN? It has like periods in it, isn't that, maybe?
No,
Is that what I'm thinking of? Okay, I don't know. And then, so we have title and genre. Those are like character fields, so that's gonna have letters. We have release date. That one's really hard to figure out. That one's a date. And then length, probably you want more information than that, but that's how we'll do that. Customer information. We call this account number because that's usually what they call it. They don't usually say this is your account ID. When we're talking about it, it's like your driver's license number and stuff. So we're gonna call it that for the sake of today. And then stuff, first name, last name, all that jazz. And then movie rentals. This is another bonus point question. We tie in the movie ID, what you're renting. We're also ignoring different copies. So we tie in the movie ID and the account number. So, and then we have extra stuff, checkout date, check-in date, due date. Why do we need a third unique identifier in this table for rental ID?
Reference it somewhere else.
That's true?
That's a complaint, you know exactly what's transaction.
That's true.
The transaction.
I'm sorry? Yeah?
And it needs to be unique too.
Right, because if I should use a complaint as an example, if I call and I say, my name is Claire and I checked out up and it's ruined, and it's the 7th time I've checked out up, they're not gonna necessarily, they can probably guess what the check-in date, the checkout date, but you know, they need a way to uniquely identify which rental specifically. Because the same person can check out the same movie over and over and over again. So you need a higher level of a unique identifier.
Technically, we could rent the same title, 2 copies of the same title at the same time. right?
Yes, exactly. So you basically, in every table, like every time you're creating a new one, because you guys are all going to become database developers tomorrow, every time you create a new table, the first thing always should be your unique identifier. And so for business case things, it can usually be something that already exists, like an account number, but for ridiculous things that's like a rental that's not really a physical entity, it's like an idea that you're tracking, you need to start with some sort of specific unique identifier so that it can always be referenced for other stuff. Sort of make sense? So.
Do you always need like a specific index for that, or can it be like a clustered combination?
So yes, you can have what's called a composite key. So right now, let's just look at movies for a minute. So that is your primary key, that movie ID. That is just what it's called as far as your like lookup field, if you want to call it that. So when it's just that one, it's just that one. You can have tables. So imagine that instead of having rental ID in movie rentals, we had account number, movie ID, and like checkout date. because the 3 of those together could be unique. If I only had 10 movies, and I only had 10 customers, I didn't have any extra copies, you could only check out one movie, one of that movie in a day. So I could look up a unique record of you renting Toy Story today, and there would be no other records of those. And that's called a composite key. So there's tons of reasons to use those in like business rules, and 100% valid. It's just usually you still slap an ID on there, because then when you're writing, it makes it easier for like, if you're writing reports or things like that, you don't have to reference 3 different columns. You can still have those be foreign keys that reference the other tables, but it's still a lot easier to just have one unique identifier and index off of that. Also for performance things, like, anyway, sorry. But yes. Oh, I'm intrigued. Okay, so that's gonna be our schema for today. This is vibrating, I apologize, let me move that. Okay, so who's ready? Buckle in, we're gonna use computers. If you don't have a computer, make best friends with the person next to you who does. What we're looking at here. So this is not what I use every day at work. This is a free tool you can use online to practice your SQL skills whenever you want. It's called DB Fiddle. You can bookmark it. It's so much fun to play with. What's really cool is, like you just saw, you can save an instance. So you can write all your schema creation scripts, save it, and then when you want to try new stuff, go watch a video on YouTube and learn something new, you can pull this back up and you don't have to write everything from scratch again. The only downfall is that it doesn't support SQL Server, so you're going to have to become a plebeian and either figure out SQLite, whatever this one is, in MySQL. But it's okay. Luckily, it's pretty much a one-to-one of SQLite to regular SQL. It's not the end of the world. Okay, so what do you think we're looking at here? And you can click this full screen thing, and we can, oh, why is it cut off? Okay, good. Okay, what do we think we're looking at here? Bingo, bingo. Exactly. So we're going to start like learning some statements that you use in SQL. So we'll just start with create. It's going to be the first thing that you always do, other than like creating your instance in your database. But you want to sort of, running a create statement is like the scaffolding of your database. So if you sort of picture it like an Excel spreadsheet, it's like generating all of these like headers for you, if you will, and it's like, I'm ready for data. I'm ready to store it. It's not creating like extra space, like a placeholder. It's just going to store stuff as you go. But you're telling it, I'm going to send you all this information eventually, so get ready to store it. So looking at our customers table, we've got account number. We tell it a data type, so it's an integer. We put not null. Who thinks they know what not null means? Yeah, it cannot, you're enforcing this at your database level. This cannot be null. This always has to be populated because you have to have a unique identifier. So you could have, like, if we had middle name, that could be null. Some people don't have middle names, some people don't provide it. But you want to have those like business rules in mind of what needs to be required and what is optional, basically. So we've got first name and last name and address. Those are all chars. It's like characters because it's probably not going to have it's not going to be all numbers, I mean. And then zip code, we don't do as a number, just anyway, and then phone number and email address. So pretty easy. Anybody notice something that we've already talked about on line 2? Yeah, it's just that easy. You just write primary key, and now once you've run this script, it knows this has to be unique, so it's going to enforce a couple things for you. One, it's got to be required, primary key. And now, once you run this script, it knows this has to be unique, so it's going to enforce a couple things for you. One, it's got to be required now. 2, it has to be unique. So if you ever made a call to store information in this table with an ID that already existed in that table, it would fail. Because now it would know this isn't unique anymore. Sorry, I can't handle that.
So how do you just get it to generate the key for you?
So you can do something, well, I don't want to write it here because I'm not that good with SQLite, but you can do an identity, it's called an identity, and you can basically, you send it 2 numbers. You send it the spawn number and the incremental number. So think about when you have an ID number on a, like from school, they always like start with the same numbers and then the ends are all different. So your SPA number would be like 3,748,000 and then increment by 1. So then you never have to send it account number. It auto populates it and always increments it by 1 every time. Super popular for things where they don't care about what the account number is. If your account number is a meaningful piece of information, if it's like your date of birth plus your whatever, that's when you don't want it to be an identity because you're going to send it that information. But if it's just, I don't freaking care, make a 9-digit number that's unique, then you make it an identity, tell it what number to start with, and it will just auto-increment it every time you add something in there. Great question. So we've got movies, pretty straightforward. Movie rentals, pretty straightforward. What do you think you see on 20 and 29? What do you think is going on there? Right. So we tell it, hey, in this table you have 2 foreign keys called account number and movie ID. And what's important about that is then we say, here's what they reference. First it's just these reference something. Then here's what they reference. So we say it references the customer's table. We tell it which field. We say account number. It's generally a good idea to name these the same thing, so it's just easier for other humans to understand. The computer doesn't care. You can maybe do whatever you want, but when other humans are looking at your database, it's nice to keep them sort of aligned. So you're telling it, okay, account number in the movie rentals table references account number in the customer's table. And now it's enforcing integrity between those. So if you try to insert something in movie rentals with an account number that doesn't exist in the customer table, it's gonna, nope, can't have it because that ID doesn't exist to me. So you would, as far as business rules, you would have to have a customer before they can rent a movie. Obviously. So that's sort of maintaining that integrity. The same thing for foreign key of movie ID. You have to have that movie in your system before someone can rent it. And then what happens is then you have these things called like cascading updates that you code in there that says, let's say you have a massive account number change. You change your system. All of your account numbers are different. If you go in and change all of those and you set it to cascading updates, it goes into movie rentals and it updates all of the IDs of customers in movie rentals for you to mimic what the new numbers are. So if my account number was 1234, we have a massive change and now it's 4 zeros. Your application would update it just in the customer table, and then your database would take it from there and update it in your movie rentals table. So that's your second layer of enforcing relationships, because it's not just a random number in your movie rentals table, it represents an entity in another table. Am I making sense? Now I'm like, okay. Then, so we're going to create the scaffolding, right? Don't tell anyone I related it to an Excel spreadsheet, they'll fire me. We're going to create the scaffolding of what we expect to send it eventually. Then, we have all these insert statements. I typed these out by hand, you're welcome. This is not normal. Normally what happens, you go into Netflix, you sign up for the first time, you're filling out a form. Behind the scenes, it's generating insert statements to populate their database. So real world applications, you're not sitting at home every night until 10 o'clock updating your database manually for your boss. It's just not happening. Those sort of inserts and updates are usually coming from an interface of some sort. There are exceptions, but just don't worry. You don't have to type these forever. So we have 10 customers, 10 movies, and then I just did 10 rentals, I think. So let's go through this. If you notice, the order of the columns in the create statements mimics the order of the information that you're sending in to the insert statement. And that's important because you're telling it, hey, I already know what the order is, so I'm going to send it to you in the same order, and then you just parse it in as it goes, first name, last name. So if I flip lines 39 and 40, it's going to think that Jim Halpert's street address is Scranton, and his city is 222 4th Street. And that's not going to end well. So that's when you sort of have to pay attention. You can also specify which values you're sending in. This is just an easier way to do it for the sake of the demo. So you just have that in mind of what order the columns are in and then populating them.
Does it have default values in case we don't?
You would populate default values up in here. You would tell it what the default is in your create statement when you're creating the thing. You could also, in your application, have it populated. If the form was null, if a field on the form was null and you need a value in there for something and you just have a business rule, if they didn't provide this information, just make it this
Or
number.
that could make a mistake and not.
Right, exactly. So that's usually you have field level validation on the front end, but you can put defaults all the way back to the back end, to the database. I mean. So we have customers, movies, and movie rentals. Look how beautiful this is. Each one of these represents a row in that Excel spreadsheet. Look how much prettier that is. I'm not storing Homeboy's address over and over and over again. I'm not storing the movie genre over and over and over again. I'm storing 1112, who is, I think, Pam? Yeah, Pam. I just store 1112, and they got it from there. They know that's Pam Beasley. She lives at this address. She has this phone number and this email. And look at that. We only have to store it once. It's so beautiful. It's ugly to look at, but you'll run reports that make it look pretty. So let's run this sucker. You're going to click Run up at the top left. You should get Query Successfully Executed at the top right, and then nothing else. But as long as you get Query Updated or Executed Successfully at the top right, and then this results, and it'll say there are no results. Very helpful. Because we didn't tell it. Huh?
It's an insert to the.
Yeah, exactly. We didn't tell it to output anything. We're not asking it to show us anything. Just behind the scenes, it's creating these tables and putting data in there. So we have, everyone got executed successfully?
Should have said committed successful.
Well, okay, listen. We'll get into commits and rollbacks in session 2. Okay, so now let's get back to our slides really quickly. Let's talk about this. This one. So we want to see our data. So right now, just for funsies, go ahead and type this. Let me make this bigger. Now, from now on, you're only going to use the right panel. Don't worry about that left panel with all the create and insert. That's your like schema building section. Now we're using the query on the side, which is like asking the database to give us information. So what do we think these 3 statements are doing?
Retrieving from the database.
Yeah, this little asterisk, which we just usually refer to as select star from, because asterisk is too hard to say in a sentence. That just says, give me everything. Just give me everything. I don't care what. Give me everything. This is like, it's 10 o'clock at night, you're debugging something, you're pretty sure that the data is wrong. You're just like, I don't care. Just show me everything at the table. I don't even care anymore. We got anyone? We running stuff yet? You can also just do one if you want it. Yeah? That's beautiful, huh? I made it myself. And the full screen thing also is on the bottom panel. So you can pop full screen and actually see it. We technically executed 3 queries here, so we've got the semicolons at the end to say that's the end of that query. So your results will be broken up into the 3 queries that you ran. So you should see customers, then movies, then movie rental information. Any issues, any problems? Sounds good? Yeah, they're just killing it? Or you're afraid of failure? Win or learn, never lose. Anyone still need this up? We good? Okay. So this is a very basic select statement. This is like your wit's end when you're debugging. You have no idea anymore what you need. You're just like, just show me everything. Realistically, this isn't what you're doing. You usually are narrowing your scope a lot more. So let's talk about the anatomy of a select statement. So just like my title, you don't have to focus on the syntax. You can always Google this. I still have to Google some some syntax sometimes because it's just the nature of it. Don't ask me what a left outer join is. I have to go look at the diagram again and okay, I got it. Like, you can always look this up, it's totally fine, don't worry about it. But let's just get basic understanding. You tell it, select these things from this place. Ready? We're gonna say it together. Select these things from this place. Look at, you mastered it. So you can list them out, comma delimited, you just leave the comma off the very last one, obviously. So you would say, for example, select first name, comma, last name from customers. These have to match your column names. So if you typed first space name, it would throw up. It would not like that. SQL isn't super case sensitive, but if you're a good developer, you still make it look pretty for the next developer who's supporting your code. So I still try to make my queries look kind of nice. If it's 10 o'clock at night, I do not. So let's get this one going. What do you think this is going to return? Oh, no, I failed. Do we need to start over? This is just going to give us first name and last name of all of our customers. And it should...
So can we just erase what we used and then write?
You can leave it up there, so you can just keep building these queries, and then you'll just have to scroll through your results window. Yes. So you can go crazy with that if you feel so moved to do so. But yes. And normally, that's actually a good question, I'll talk about that. So normally a lot of us will have saved queries, to keep going back to like developer point of view, not business point of view. A lot of us will have saved queries. So for example, my company does baking software. So we have tables like user information, and then we have account information, and then we have user account information. And like you need to link all these together. So a bunch of us will have saved queries that we just have to drop in like the user ID or something, and it will, we've already written it all out, so we don't have to retype this same query over and over and over again. And that's basically the logic behind like a nightly report. So if you had, for example, when I worked at the cattle company, I made an application for our safety manager. So you can imagine if you've got a bunch of pen riders and like people who work in a cattle field, they need to be trained on specific equipment, and that training, that safety training expires at a certain point. Homegirl was maintaining a physical binder of paper where she would flip through every month and see who needs to be retrained on what. So built her this application where she can digitize all those records, and then every month at the first night, it runs a report, which is just running one of these select statements, that prints out a list of who needs to be trained on what this month. And then that's just an example of like something you would save. Anyway, now I've read a lot about saving queries. Did you have a question? Okay, never mind.
No, I actually wrote that down and saying that table names that exist. Do I just pick a table, or do I literally say?
Oh yeah, so this syntax, like this will work for what we've already created. So from customers. Oh yeah, sorry, this is the example. I probably didn't do this, sorry. I probably should have labeled this slide. I'm a developer. This is the best slide deck yet. Yeah, so we go over this first one. That person was just to give you an idea of the anatomy of a select statement. No, totally okay. That was on me. Just this bottom one is what you're going for. First name, last name, and customers. If you created a table called table_name, and then column 1, column 2, this will work like crazy. That's probably not good naming convention. Don't do it. Okay, so we good. We see first name and last name. It was really exciting, and we all high-fived, and okay, cool. So normally, right, we're not going for everything. We're looking for something very specific. We want to see, all right, Michael, how many movies do you have out? Okay, Pam, what you got going on with your account? So, in comes the where clause. Basically, like as you're getting more and more specific with your SQL query, you're just tacking on more and more keywords at the end of this. So it's always select from, then we're going to add this little where, maybe we throw a join in there. So now we're going to add this where. Again, this first one is an example. Sorry, everyone. Don't use the first one. The bottom one is if you want to type to work for us. So now this is sort of your where clause is narrowing down. So it's saying where first name is equal to Michael. Assuming I typed this correctly, what should this return?
How many have first name Michael?
Right.
Last name could be different.
Exactly, yeah, if we had more than one Michael, it would return anyone whose first name is Michael. Probably should have done something that would return more than, use your imagination. So did we get something pulled back? Did we get data? Okay, cool. Because we're gonna rock and roll, and then we're gonna do this cool join, and then you guys get to just go crazy, and I want you to like generate your own things. Okay. Well, we'll skip this one. We're gonna do the join first. So I'm really good at naming things. Go to bit.ly/cooljoin. This is case sensitive. So go here really quickly, and then you can take your time. And then we're gonna introduce joins. So let's talk about them for a second. Well, our linking tables, like movie rentals. When you just look at that data, it's hard to figure out what's going on. There's just all these numbers that are completely arbitrary and then some dates. And you and I know what that means, but like, we have to be like, okay, 1112 is which one? We have to scroll to Pam and like, okay, yeah, that one's Pam. Nobody has time for that. So you want to do things where you're joining tables, you want to use that relationship that you have established between your foreign keys and start joining tables together, and then you just get to say, I just want this information from here and this information from here. Because realistically, if we're talking about using reports, and I think I already even mentioned this one, spoiler alert, what is a daily report that a movie rental company would be running? Right, late. So we have very specific data points we would want in a late movie thing. We would want first name and last name probably. We would maybe want phone number if we're going to call them, or email if we're going to email them, or neither if you just know who Michael Scott is and you're just going to show up at his door. We probably want which movie is out late, because maybe he has 10 movies out and only one of them is late. Then we also want like when it was due and maybe a calculation of how much he owes us. And that is customer information from our customer table, right? We want his name and maybe number. That's movie information from our movie table. We want to know what title he's got right now. And that's checkout information in the middle. So we can't just write a select and just say, go select all this stuff. We have to tell it, join this one, and join this one, and use these relationships that I built before to then make it really pretty. Because otherwise, if we just go look at movie rentals right now, it's going to be like 1111, and then 4744, and then a date, and then that's not fun. So, do we have cool join up? Did I type it correctly? Okay, things are going well. So this isn't it, because that's going to be your challenge. But let's talk about the anatomy of a joint. I think I can zoom in. Cross your fingers. Things are going terribly. Okay. Oh God. Everything's falling apart. Make this full screen first, and then zoom in. Yeah, look at me. I'm a professional. Okay, so let's talk about this. This is a doozy. So we're going to sort of, for this one, we're going to start in the joins and then we're going to work our way out. I know that's a little crazy, but just go with me. So on line 11, we're selecting from the movie rentals table. So generally we want to start, well, at least for this case, we're going to start from our linking table because that has most of the information that we need, and then we can use what it has to go out and get the other information, right? So our from in here is officially for movie rentals. And then we gave it a little alias right here. Memorize all this just for funsies. Basically, instead of having to type movie rentals dot whatever over and over and over again, you can just do MR. So that's a really fun way to spend a Friday night. So then we want to say, okay, so take your movie rentals table. Then I want you to join to the movies table. And it's right there, but what do you think we want to join on for those two tables? How do they know each other?
Number.
Yeah. So we take that movie ID that's in the linking table and we basically tell it to go look it up in the movie table and go get all the information that is associated with that. We're going to limit what it's actually going to return, but it's like armed and ready to have all of that information ready. Then we're also going to join the customers table on what? Account number. And see, now that we use these aliases, it's so much shorter and so much easier. And it's nice that we named our foreign keys the same in both tables, because then it's account number and account number. It's very clean, it's easy to read. I know this looks a little crazy up here, but in general, you can follow this pretty easily. That's why, just like in code, it's nice to like name things with meaningful names and sort of keep things consistent. So now we have all this data, right? As if we're like in bullet time, right? We're starting in movie rentals, we get this ID, we go over here, now we have ready to go an entire record in the movie table. Then we're also going over to the customer table. We've got ready to go all of the customer information, and we're like, okay, babe, what do you want? I got it all. So that's when we tell it what specifically we want. If we did a select star here, it would just give us a giant word vomit of everything from all three of those tables. It's useless usually, so don't do that. But so we're gonna do a couple different things. First, we're gonna do things like title, checkout date, and check-in date. I don't know why I didn't. Well, let's not mess with code that works. Let's leave this alone. But usually you would specify which table these are coming from. If you know for sure, like checkout date is not in the customers table, that's fine, but it also just makes for a cleaner thing if you're specifying which table. So those 2 through 5, pretty straightforward. Just get me the title, get me the checkout date, get me the check-in date, and get me the due date. This first one right here that we're doing, who thinks they know what's going on there? I know the pipes are kind of weird. Thank you, Super Light.
Taking the two fields, putting a space in between them and making them a new field.
Yeah!
Making it a name.
Yes, exactly. Bonus points. Also, I heard you say decatenation.
Oh, yeah.
Love it. So yes, exactly. As far as data integrity, we don't want to just store name in one field, but if you're looking at a report, it's a lot easier to just look at first name, last name. So now we can tell it, go get first name, then these pipes are a way of saying, put this together. Then we give it a little space in between first name, and then we stick on last name on the end, and then we give it a name that's just called name. But we can put customer name, you can name it whatever you want. If this is a late report, you could put, a mean term in there, like losers who owe us money. And then, just as like an example of how queries can sort of go crazy and do whatever you want, we added a case in here, like a switch case. So, extra bonus points. What's going on here?
You calculate whether it's late.
Not quite. I mean, it is, but it's doing something with that information. Yes. So we have over here as status, so we know we're creating our own column name. It doesn't exist. We have a case that ends here, and we say when due date is less than check-in date. So if this was due last week, it's not good. Or, how did I write this? Yeah. And then if due date, this is a while ago, I apologize. Due date is less than today. Yeah, I figured it out. I got it. So this is ones that have already been checked in. We just want to like label these as like homeboy kept up for 3 extra days. It's so sad. Why would you do that? And then these are ones that have not been checked in yet, because check-in date is going to be null if you still have it at home. So if either of these things are true, if it was late at some point, or if it is late right now and it's still not checked in, then I want you to put late in that column that we're creating. Otherwise, 2 dashes, whatever you want. Let's put home, boy, or girl, let's spell it right. Boy or home, girl is good. All right, cool. There we go. Then we're gonna name that status. So let's find my anti-full screen button really quickly, and let's run this. And let's hope I can screw up my syntax. Okay, cool. Here, now I changed mine a little bit, but y'all can hit run and see what you get. Look at this meaningful data we have. We don't have any ID numbers that we, can't really do anything with. It's just like humans looking at it. We have exactly the information that we need as far as who has something checked out, what they have checked out. We have some date information in here. Honestly, maybe we didn't even need all of the date fields. Maybe we just needed to calculate it and then say late. And then we've got our other computed field over here that gives you the little status. Does that make sense? When you just cook it with gas?
It's the first and last name, there are multiple of them, you probably need another qualifier that's meaningful.
Yes. So if Michael Scott has 400 movie titles checked out that are late, is that what you mean?
No,
Oh.
if you might have Michael Smith, multiple of them.
Oh, I see what you mean. Sorry. Yes. If there was more than one Michael Scott in the database, this is probably tough. That's probably why we would want email. Just actually,
Email it.
let's just put that in there. Let's not put it after title. That doesn't make sense. Let's put it right here. Let's put, what did I name it? Phone? Just phone. Okay. Let's run this. Now, even if there were 47 Michael Scotts, we have the specific phone number of this Michael Scott that owes us money. And like a lot of money probably. I don't remember what these dates are. Oh, that's only 2 days late. It's like $1.50. So this is just one of those things you would sort of create this behind the scenes. Also, you don't have to type this out by hand. If you have a program that's handling all your check-in, check-out things, it usually has, sometimes, these sort of software, pieces of software have report generators built in. So you would have like a pretty UI where you have like drop downs or whatever, and you're saying, this is the information that I need, and this is how often I need it, and stuff like that. And you build it out to say, run this report every night, and behind the scenes, it's generating a query like this to say, okay, get me first name from here, get me last name from here, get me movie title from here, put all of this information together, and then email it to boss man in the morning, or boss woman. Okay, so now it's a free-for-all. Honestly, I didn't even know if we were gonna make it to joins, but I guess I just got excited and got talking really fast. So now I want y'all to go crazy. Google is your friend. I'm gonna be floating around. Maybe I'll even go up here and type some stuff too. I want to see some meaningful, what's the word I'm looking for? Just select statements, like meaningful things that a movie rental place would want to run, or just a fun thing that you want to see. But go crazy, homework time. How many times each movie has been rented? Who did that one? Oh, did you guys do all of them? So, okay. Are you having to use the Julianne Day one? Because
That's like I'm using Julian Day to that and
interesting. Okay, let's see if we can work through this together. Oh, sorry, I forgot that I'm extending and not duplicating. Hold on. Let me learn how to use a computer. Here we go. Maybe? Okay. Because it was not nice to me. This is what we call peer programming. Okay, so we're gonna, I always just start mine with select everything and then I'll come back later. I want to build out my logic first and then come back later and figure out what columns I want. So I'm gonna all select everything from, I'm gonna start at movie rentals, right? You don't have to. I just usually start at my linking table and I'm gonna name it MR. I want to join, let's make sure that this syntax works because actually if I do that every time it's not gonna be good. We want to join movies on what? Yeah. And then we want to join customers on account number. Oh, I did it. Let's do it. Let's be the same. Okay. Good Lord. Live coding is not my favorite. Where right now I'm just going to do 1 = 1 to test the syntax of all of this. Oh, good. What? I didn't ask for you. Okay, let's see what we get. See, it was not happy with me a second ago about mine. Okay, that's everything. Obviously, I don't want all of that. So, can I, like, half-sies do this? No, let's do this. Okay. So what columns do you think we want? Or let's do the where first. I like to fill out the where column. What sort of logic are you going to put in this where? Right? Let's make sure we're specifying. It looks like Mr. Check-in date. Is null, right?
And the due date is less than now.
Yep. Is that the syntax for select
I
now?
use it for both. Because we have that.
Is it not date now?
Sorry.
Is it what?
Date.
Instead of which one? Hold on.
select now, but there's no date in front of it.
Oh, yeah. Thank you. See, listen. That might be what I was doing wrong with the other one. That's probably right. Let's see. Oh, see, it's math. Hold on. Did I type that right? What did I do? See, this is, well, okay. I got rid of that. This might be wrong. So now, let's comment out my where and see if this did it, or if this whole thing is broken. Okay, my where broke it. That's fun. Let's comment this out. Life of a developer. Okay, so this is math. Let's throw parentheses around everything. Didn't we do this in the other join? Didn't I use this thing? Oh. I think this select has to be in its own parenthesis world. Can I scooch this? No. Okay. Do I have too many parentheses now? I think I have just enough. Let's see. Okay. So we've got our where done. We want to make sure that it's not checked in yet and that due date is before right now, so it's late for sure. Then we probably want what information to display. Yeah, let's do that. First name, last name. Okay. Let's see if this no. Oh. Did I put this? Did I spell last name wrong? Ooh, that looks the same. I still don't think it's gonna like it. Let's skip this. We'll figure that out later. Okay. Okay, so we're gonna do first name and last name. Ooh. I'm doing so great. Listen, I'm not being paid for this, so you're getting what you paid for. Okay, so we've got first name and last name. Everything's going great so far. Nothing's falling apart. Okay, so now we want to try to calculate. So I'm going to say it's $1.50 per day. We're also going to pretend that it's all the same change, or all the same, you know what I mean? There's not differences between new releases and things. So we want to calculate a column, and we want to probably do it in the number of days that we're past the due date times $1.50, right? You with me on logic? It's basic math, but now everything's gonna crumble because I've never done this in SQLite before, so you're watching me learn firsthand. That's right. That's right. Then, yeah, I think this one's just, has anyone gotten the, ooh, this one doesn't line up. So this one goes here. So we need another one there, another one there. Okay, let's try it. This will be homework otherwise. Okay. Y'all follow me on Twitter and then tweet me when you get this working, because I'm gonna go home tonight and try to get this working. It's gonna drive me crazy. But I also want to be conscious of your time and not sit here and debug live, because even I would fall asleep during this. So let's review really quickly, because we're good presenters. We talk about what we're going to talk about, then we talk about it, then we talk about what we talked about. So, bad data. What is something that makes bad data bad? Huh? Excel, yeah. I thought you said it sucks. Just accurate, yes. Excel makes bad data bad. What else? Yes, no separation of concerns.
Duplicated data.
Yes, any duplicate data, anytime you're repeating yourself, bad news bears. And you don't maintain the relationships, the integrity of the relationships between things. That's like the most important thing. Why our database is important. It's the opposite of all of those things. We're limiting our duplicate data. Obviously, you're going to repeat some things, right? We were repeating account number over and over and over, but it's a lot easier to repeat a 4-digit number, for example, in your linking table than it is to repeat your entire record of your customer over and over and over. It's also maintaining those relationships between your data so that you can do joins and you can say, go get this information based on this little bit that I'm going to give you right here. So you don't have to say Michael Scott at this address and whatever. You can just say customer number 1113 and it goes and handles all of that. What is an entity relationship diagram besides the thing you're going to take home and frame? Because it's just so beautiful. What do we use ERDs for? I know you all know this. Yeah, just for our visual data modeling. It's really good, especially in the very beginning of a project, to draw them out, and then ultimately it's a great reference later on. Once you've established how your program works and you've got all your databases built, you'll usually have one of these that you can reference in some sort of documentation. So when someone new onboards or a client has a question about how something works, you can refer to this diagram rather than having to like dive into the database specifically, and you can say, oh, these are how these two tables are related, which is nice. What is normalizing data? Huh? Yes, exactly. Anytime I think normalizing, I think abstracting. Anytime you're repeating yourself, that's not normal. So normalize your data, don't repeat yourself, keep your data dry. And then obviously we got to do some create statements, some inserts. There are updates, that's another day. There's also a cajillion other things that you can do with this. So now you have DB Fiddle at your fingertips. I also have these sample scripts on my GitHub account. So if you're ever curious and you want to see more and test out more, feel free to reach out. And then I think that's pretty much everything. Other than that, thank you all. You've been wonderful students, and you got to see that even I make mistakes and can't figure out syntax sometimes and have to Google it. Now I'm going to figure out, although I never use SQLite, so I don't know.